starts on page 6 at the bottom of the page. And the first part is going to be just a simple review of Pythagorean theorem. Remember, Pythagorean theorem works for right triangles, where you've got a leg and the hypotenuse. So remember, the legs are interchangeable. So if I label these two triangles, that could be a leg, and that could be a leg. Remember, your hypotenuse, the longest side, is always directly across from your right angle. That one doesn't change, but the other two can. They're interchangeable. All right, so the one at the bottom says to actually apply the Pythagorean theorem and find that missing side. So I'm trying to find my hypotenuse, that's c squared. So I'm going to take a squared plus b squared, simplify that out, so 9 plus 16 equals c squared, 25 equals c squared. So now I don't want c squared, I want c all by itself. So I'm going to take the square root to get rid of that squared, and c is 5. So my missing hypotenuse is 5. Alright, top of page 7. So for this first one, here's our right angle. So we're trying to find our hypotenuse. So 4 squared. Now my advice would be, you know you're going to end up having to take the square root of it anyway when you're trying to find the hypotenuse. So go ahead in your calculator and put this in there. That's going to go ahead and do it all in one step for you. And you get 4 root 5 or 8.9. Alright, the next problem you've already got your hypotenuse. So you're looking for a leg. So, same formula. But this time, I know A and I know C. So this just comes down to solve an equation. So 3.9 squared is about 15.21. 11 squared is that. So I'm going to move that 15.21 over, and if you just left it as 15.2, that's fine. So I'm going to subtract, and I get that. Now same thing, I don't want b squared, so I'm going to take the square root, and that missing side is that. And you could have done 10.2, 10.3, all depends on how you round. The last one works the same way, because I've already found my hypotenuse, so I need the other leg. Alright, so simplify. I'm going to subtract 12.96 from both sides and get b squared by itself. To get b really by itself, I'm going to take the square root. And I get that as my missing leg. Okay, so all of Pythagorean theorem review to get ready to do this part. The ratios of right triangles to actually define those functions, those trig functions. So here's our right triangle. We've got our hypotenuse, which is still the same thing, but this time it's thrown in that. That is theta. Theta is just some angle. I'm sure you remember SOHCAHTOA from last year. Well, that's this again. So to find that sine, cosine, and tangent, to determine what's opposite and adjacent, depends on where theta is. So everything that is determines what's adjacent to it, what's opposite to it, so on and so forth. So in this one, with theta being right there, here's its opposite side, and here's its adjacent side, the one right next to it. So here are your 6 trig ratios. You've got sine, cosine, and tangent. Then you've got their opposites. So the opposite of sine is cosecant. The opposite of cosine is secant. The opposite of tangent is cotangent. The way to remember sine, cosine, secant, and cosecant is each one of them has an S and a C. No 2 S's together, no 2 C's together. And these, remember, are just flipped. So where sine is opposite over hypotenuse, cosecant would be hypotenuse over opposite. And remember, that all depends on where theta is. So, top of page 8. So we're going to just label using opposite, adjacent, and hypotenuse. So here's theta here. So its opposite would be here, meaning this has to be its adjacent, and the hypotenuse is always right across from that right angle. That one's a given. So the second one, here's my hypotenuse because it's right across from the right angle. Alright, so here's theta. Its opposite is here. So that means adjacent has to be here. Alright. Last two. Here's my hypotenuse. Opposite of theta. And next to theta, which is adjacent. Alright, last one. Here's my hypotenuse. Here's opposite of theta. And here's adjacent to theta. Okay, so now we're going to put all that together and actually evaluate those 6 trig functions. Sine, cosine, tangent, so on and so forth. So the first thing we need to do is we need to do Pythagorean theorem to find that missing side length. So step 1 is Pythagorean theorem. So you've got a leg of 3 and a leg of 4. So when I do my Pythagorean theorem, I get 5 as my hypotenuse. Alright, then to make it even easier for yourself, I would say label opposite, adjacent, and hypotenuse on that triangle. So here's my right angle, but that's my hypotenuse. Theta is in that corner, so its opposite is the 4, and its adjacent is the 3. Okay? Now we've got our SOHCAHTOA. I like to write it like that. That way I can actually see hypotenuse over opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. So sine, we're going to put our opposite side over our hypotenuse. Cosine, we're going to put our adjacent over our hypotenuse. And tangent, we're going to put our opposite over our adjacent. Now, the one thing you want to make sure you do is, can you simplify your fractions? I can't simplify 4/5, I can't simplify 3/5, and I can't simplify 4/3. So my fractions are as reduced as they get. If all else fails, plug into a calculator and test it. Alright, so now I'm going to find their inverse, or their opposite. To find my cosecant, I flip sine over. To find secant, I flip cosine over. And to find cotangent, I flip tangent over. So there's my 6 trig functions, my 6 trig ratios. Alright. So first thing we want to do on this one at the top of page 9 is find our missing side. So first thing we're going to do is Pythagorean theorem. This time we're trying to find a leg. So we've got 25. Move 25 over. Now, I'm hoping some of you are thinking, why is it not positive -12 when you took the square root? Remember, these are talking about side lengths. You can't have a negative length. So in this case, it's just that positive 12. All right, so we've used our Pythagorean theorem to find our third side length. Now we want to label it. Here's our hypotenuse. There's our opposite. And there's our adjacent. So we've got opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So our opposite would be 12 over 13. Cosine would be 5 over 13. And tangent would be 12 over 5. I can't simplify any of my fractions, so now I'm just going to flip them over. Cosecant, 13 over 12. Secant, 13 over 5. And cotangent, 5 over 12. Alright, pause it, and you try these next two. Alright, after I do Pythagorean theorem, I get that side length is 13, and that's going to be my hypotenuse. There's theta, so its opposite is here. Adjacent is there. So we've got sine, which would be 5 over 13, opposite over hypotenuse. Cosine, which is adjacent over hypotenuse. And tangent, which is opposite over adjacent. So now we're going to flip them. Remember, cosecant goes with sine, C and an S. So that's going to be 13 over 5. Secant goes with cosine, C and an S. And cotangent, flip tangent over. And none of those fractions will reduce. Alright, the next one, we found our missing side to be 8 after Pythagorean theorem. So now you've got hypotenuse here, opposite here, and adjacent there. So our sine is going to be 15 over 17, 8 over 17. Now flip them over. Alright, last two. Go ahead and try these two. Alright, missing side, 25. That is also our hypotenuse. So there's theta. So 15 is our opposite. Makes 20 adjacent. So your sine, your opposite over hypotenuse, is 15 over 25. Now that fraction I can simplify. 15 over 25 is 3 over 5. Simplify your fractions. So cosine is 20 over 25. I can simplify that one too to 4/5. Tangent is 15 over 20. I can simplify that one. That would be 3 over 4. So now for cosecant, secant, and cotangent, I'm going to use my reduced fractions. Because even if I use 25 over 15, that's still going to reduce to 5/3. So I'm going to save myself a step and just use my reduced ones. Alright, last example. Missing side is 19.8. Using my Pythagorean theorem. So we've got hypotenuse here. There's theta, opposite, and and adjacent. So we've got 7 over 21, which we can reduce to 1/3. Then we've got 19.8 over 21. Then we're going to flip them over. When you flip 1/3 over, you get